Hey everyone, what we want to talk about right now is going to be the notion of doing filtering. Now, one of the tools that we have in our toolbox is not very surgical, but it does allow us to be able to perform traffic filtering, and by virtue of the fact of filtering traffic, it's going to allow us to be able to manipulate how information is going to flow through our infrastructure. So right now what I have is I have on R22 in the data center, I have the ability to be able to load balance through R2 and R3 to reach the interface of, or the loopback 0 interface of R1. So let's illustrate this. So I've got 172.16.1.0/24 on R1, and I'm going to do load sharing to be able to reach that using these paths. So again, from R2 to Cat1 to R1, from R22 to R3 to Cat2 to R1, and that's going to allow me to do load sharing. Now, this idea of being able to use passive interface is going to say, well, I don't want to form a neighbor relationship across a link. That's going to allow me to say, okay, well then what I'm going to do is I'm not going to advertise prefixes across that link. By virtue of the fact that I do not form a neighbor adjacency, I'm not going to advertise prefixes. Now, this is kind of like route filtration with an atomic bomb. But the main goal here is to recognize that if we're backed in a corner and it's the only way that we can do it, we do have the capability of employing this method of filtration. Now, the way we're going to do this is I'm going to go and I'm going to say, well, what I want to have happen is I want traffic to follow the path through R2. And the way I'm going to do that is I'm going to go to the serial 2/1 interface of R3 and I'm going to make it passive. So let's do that. So what we'll do is we'll go to R3, router, EIGRP 10, and I'm going to say passive interface. And the passive interface that I want to do is I'm going to say passive interface for serial 2/1 and hit enter. Now that's going to cause my neighbor adjacency to drop. Now we saw, based on my previous output, that I was load sharing to reach this destination through 2 and through 3. Now if I repeat that command, trace route, what we're going to find is I'm going to go to R2 to Cat1 to R1. Now the reason being is we're not learning any prefixes from R3. So we have nothing in our table. Let's do a show IP route or IP EIGRP topology table. And what are we going to find? What do we learn from anything from serial 2/1? So let's modify that. Let's say show IP EIGRP topology include serial 2/1. Well, we've got it connected via 2/1, and that's going to be the only entry that I have in my routing table. Show IP route via, actually I'll just do show IP route, and what we'll see here is we'll do show IP route connected. And that's why I'm going to have that entry in here for serial 2/1. Here it is. I'm going to have the two entries, the connected and the local route that I have in my routing table, in my rib. So when we look at this, again, this is going to be really handy, but what happens if I were to lose my connection to 2.0? Let's look at that. So config T interface serial 2/0 shut. And what's going to end up happening is this link is going to die. And since I'm not going to form a neighbor relationship off the connection from R3, now I'm going to lose all of my prefixes. So do show IP route, EIGRP, and I'm learning nothing. All because the passive interface is preventing me from forming a neighbor, therefore it's filtering all prefixes that are going to be communicated by my EIGRP speaker, and I physically shut down an interface that's connected to the only option that I have with regard to being able to communicate with the rest of the EIGRP infrastructure. Now what I want to do is fix this. So let's say I'm going to say no shut. I'm going to go over to Cat3 and I'm going to remove the passive interface command. That means if I go back over to R2 and I repeat my trace route, at some point I should start load sharing when my link comes back up. So let's see, I'll repeat it, and now I'm load sharing across R2 and R3. So like I said, it's kind of like troubleshooting with an atomic bomb. Not troubleshooting with an atomic bomb, it's kind of like filtering with an atomic bomb. But it does give me the capability of being able to stop reachability in my infrastructure and make certain that I can ensure that data goes through another path. Now the thing that I want you to understand is if I return to R3, router EIGRP 10, and I put that passive interface command back for serial 20, that doesn't mean that I can't reach the other end of this, because it's still going to be advertised. So what we're going to do is, if we look at the links in question, on this connection right here, we have 10.1. Let's see, it should be 223.024, and this one right here should be 10.1.222.0/24. Now the question is if I go to R22, do I have the capability of reaching this prefix right here? And yes, I do. So let's do it. Let's just double check, make sure I'm not talking out the side of my face. So we've got R22, ping 10.1.223.3, and I have reachability. Let's do a trace route to 10.1.223.3. Now look how it's traveling. It's traveling all the way up directly to R3. Now hold on here, something's R3. Did I do the no for that? Serial 2.1. That neighbor's down. It's going to, oh, I see why. It's going to 223.3 because that link is connected. So it thinks it's this local. So let's do this. So what I'll do is I will see, can I reach the loopback? Let's do that. So we'll say 172.16.3.3 and do the trace route. And what we're going to see is it's going to go to R2, and from R2 it's going to skip across that line to R3 using this link right here. And it has reachability. So we don't stop advertising a prefix by virtue of the fact that we use the passive interface. All we're doing is saying we're not going to use multicast communication, and the moment we enable the passive interface configuration in an EIGRP configured network on a link, we're going to break our neighbor relationship, but it doesn't affect the fact that that EIGRP speaker is still going to advertise that particular interface. So like I said, it's not very safe, but it is an option, and we may find ourselves forced in a situation where we have to entertain this type of scenario or situation. So with that being said, let's look at some more realistic tools with regard to doing route filtration. I'll see you guys in those presentations.